blocks are, well, they're not the same. They don't have the same height. So there are 2 blocks here. There are 4 blocks here. I don't know, 2, 4, 2, 4, 6, 7, 7 blocks here. Okay, let me just put the number of these blocks here. So there are 2 blocks here. There are 4 blocks here. There are 7 blocks here, and there are 11 blocks here. You can see that, right? And what I'm saying is that they don't have the same height. So, well, according to the number of blocks, that's exactly the height. So this is, if each block is 1 meter, so this is 11 meters high, this is 7 meters high, 4 and 2. And the question is the following. You see, what happens if I just want to have a uniform height for all of them? So what I'm going to do is I'm going to do this. Okay, sorry. Let me just take a copy of that. Okay. Put it here. Right. Okay, so let's see what I will do. First of all, I will just take these two. See these two, and I'm going to put them here. Is that okay, Ashram? Right, and let me just oh, sorry. Let me just choose the other eraser, small eraser. Okay, so I'm going to remove these. Is that okay with you, Ashram? Do you mind if I put them there?
Yes.
Okay. Now what I'm going to do, and I'm going to put these 2 blocks also here. So actually, I'm removing these here. Okay. And finally, I'm going to take these 2 blocks here, okay, and put them here. So I've just deleted those 2. Now, this set has the same height. Okay. So let's just say, so they have the same height. Same height. And this height is now is what, Ashwell? 2466, correct? But in here, each one of these columns had different heights. So this is what we call the average value. Right? What do you mean by the average value? It means that if everything has to be uniform, then to what height these are going to rise, all of them, yes, right? And the way that we do this is the following. We say we just take 2 and add it to 4, add it to 7, and add it to 11. And how many blocks are sideways here? There are 4. Yes, so we divide that by 4. So you should be able to get that 6. Right? So we add the individual heights. So this height with this height with this height with that height, and we divide by the number of heights here. It's just like, so this looks like a actually a rectangle. Yes. Okay. This looks like a rectangle. So eventually, yes. So a rectangle actually has what? Has a base here, which is, let's say, A, and this is a B. So the area of that is just AB. Of course, if you want to divide this by blocks, it doesn't really matter. So it's just A times B. And if they have different A's and different B's at different A's, so what you want to do is that you want to calculate the area of all of these blocks and divide that by A. Yes, so you get a uniform B. All right, so once you have the area here, you divide that by A, you should be able to get B, because simply the area is nothing but what? So is A times B. If you have the area, then you just divide by A, you get a B. Divide by B, you get A. So that's what it is, basically. Do we understand what we mean by the average value of a function as well? Well, these are blocks, they are not functions. Okay, do you understand the process from here to here?
Yes.
Yes.
Okay,
Yes.
so that's easy. Interesting thing here is that well, these are simple, and the reason why it's simple because they are blocks. You can just take as many blocks as you can. But if you have a function that goes as such, that from a certain level here, let's say from let's say this is x1 to x2, let's say, you really don't have much height. So see, where are the heights? Where are the blocks here? I mean, you don't have anything like this with blocks. Well, actually, you have infinitely many heights. So this is one height. This is another height, another height, another height, another height, another height. So, and the question is the following. We see, what is that height that is going to make what? That is going to make what? What's the question here? What should I ask? What is
What
that height?
going to make a
What?
rectangle?
Make a rectangle of what? Of what kind of area? Of the same area as the original area, correct?
Yes, yes, yes.
Yeah, if you think of this as sand, okay, and there is a pile of sand in 2 dimensions, let's say, and you shake it. So this sand is going to fall down, correct? It will fall down something like this, correct? And it will have a horizontal top. So eventually what we're saying is that this extra sand has come actually from this side, correct? Well,
Yes.
yeah, so now, so the original area, when I'm saying the original area, which is this area, original area, this area, should be now the area of what? Should be the area of
Rectangle.
the rectangle, and this is what it is. So this is how so actually we are balancing what? We are equating what? What's the word for this? Equating, yes. Equating areas, isn't it? What did I show?
Yes.
Yes.
Okay, fantastic. So this, we know what this is now. So so that's the whole story in a summary. Yes, I have a function, which is this function here. This function, okay, right? And I'm saying if this is composed of sand, then I shake the sand. To what level is this going to come? All right. So the idea is very simple. Let's say, okay, the final area of the rectangle is going to be the area under the original graph. So if I just integrate that function from a to b, f of x dx. So that is supposed to give me an area, isn't it, Asham? Right? Now, if I just divide, so it's an area, and that should be equivalent to this area. But this area is what? What is this length? Is b minus a, isn't it? And this
Yes.
is what? This is the height, or what do we call this height?
F average.
Exactly, this is the average value. So now the area of this rectangle is b minus a multiplied by f average, has to be equal to the area under the original function, okay, f of x dx, and therefore my average value is nothing but the area divided by the width, which is b minus a. It's as simple as that. But the idea is really very simple. What is the average value of that? You have an income today, 7 riyals, tomorrow 15, the day after tomorrow is probably 6 riyals or 8 riyals, whatever, 100 riyals, etc. So what is your average income in a month, for example, if you're working on a taxi, for example? So this is all right. So this is the average value of a function, which is no, this is not what the average value is. So this is the average value of a function. Let me just summarize that. Okay, so the average value of a function on an interval is equal to what? It's the width of that interval, 1 over the width of that interval multiplied by the original area. And that's it. Okay, good. It's easy. You see that there's much of mathematics here. Okay, let's just take some examples. Okay, use an example. Okay, so we want to find the average value. Find f average of f of x, which is equal to x squared, and then 1 plus x cubed on this interval, 0 to 2. Okay, so we say that the average of that function is 1 over the width of the interval, which is 2 minus 0, times the integral from 0 to 2. This is x squared, 1 plus x cubed dx. I am not going to do any integrals because this is not the objective of this class, so I assume that you will be able to do this integral, and then you get an answer to that. Okay, another example is you want the average value of the function f of x, which is the cosine x on 0 to pi over 2, right? Which is, we want this actually. So this is pi over 2. So what's the average value? The average value is something like this, yes? It's possibly here. Such that the area, the blue area under the blue curve, is equivalent to the purple area, or this area, actually. The yellow area, let's say. Okay. All right, so, okay, so we say the average value is equal to 1 over pi over 2 minus 0, and then the integral from 0 to pi over 2 of the cosine function dx. So that should give you this side, yes? Okay, and you can do that, of course. Right. Okay, so okay, this is just, is this okay, Asham? This is extremely simple. What you want to do is that you want to see which rectangle is equal to the area of the original function, under the original function. So the area of rectangle is the width times the height is equal to the original area, and if you want the height of that rectangle, then you divide by its width, basically. So this is what this formula is telling us. Do you have any question on that, Asham? I hope this is straightforward, yes. Right?
Clear.
Is that okay? Fantastic. So let's just go to the last chunk of it. This section is really a little simple, so is it much here? Okay, so this theorem is a very fundamental theorem. It's just like the mean value theorem for functions, like you did in Math101. We have a counterpart here, which is the mean value theorem for integrals. And this theorem is saying that if you have a continuous function on a closed interval, so there is a closed interval here, and this is a to b, and this function is really continuous on that interval. So that's very important. So this, we're talking about continuous functions. All right, and what this is saying is that the average value is obtained during the interval. Okay, let me just give you a physical example. Suppose, listen to me carefully. You start from 12 noon time, and you go and reach Riyadh at 4 p.m. Of course, you gentlemen reach much earlier than me. I take 4 hours, right? And so this is a 400 kilometers, and I spent 4 hours to do that. So what was my speed, Shabab?
100 kilometers.
100.
Yeah, it's 400 divided by 4 hours, which is 100 kilometer per hour. Okay, so this, I would call this the average speed. Yes. Why the average speed? Because this really did not. I did not go over 100 kilometer per hour all the time. I stopped at the gas station, stopped for anything else, and then I speeded up at certain times, etc. Checkpoints, whatever. Yes. All right. So, but this is an average value, correct? Now, what this theorem is telling us, please listen to this carefully, is that at some time between 12 p.m. or 12 noon until 4 p.m., this 100 kilometer per hour was obtained. If I come and tell you, Shabab, that I traveled from here to Riyadh from 400 kilometers in 4 hours, but I never drove at 100 kilometer per hour, would you believe that?
That's impossible,
Yes.
I think.
It's not possible, yes? So that's your average value. So like I say that I was driving at 80 kilometers, and then I drove at 120 kilometers per hour. Is this possible?
No,
You couldn't jump. Why? Because the function is what?
continuous.
Exactly. So the speed is a continuous function. So you can't go from 80 to 120 all of a sudden. You have to go through the 100 somewhere there. So this is what this theorem is telling us, that for continuous functions, the average value must be obtained. You cannot skip the average value because that function is continuous. Okay. So if you go from here to Riyadh and you claim that you went over an average speed of 100 kilometers per hour, that's the average value, then you must have got this speed at least in 1 second in your life, yes? Or a fraction of a second, whatever that is. Yes. Okay, let's just read this statement again. Okay, if you have a function that is continuous on a closed interval, then there exists a number in this interval from a to b. Okay, so this is the function that is continuous. There will be a number here, c, such that the average value, so this is your average value. So there should be a number, at least one c here, where the average value is obtained. So there has to be f of c, which is equal to f average, is equal to that, right? There, that average value is obtained. You must have a c that belongs to what interval? To the closed interval. Could be at the endpoints, right? It's possible. But you must obtain that average value at least once. So this is what this theorem is telling us. You cannot escape the mean value for continuous functions. And let me give you an example, elaborate on this. Here is an example. Find the average value of the function and then find a value c such that f average is equal to f at c, right? And my function is given by this, is what is x minus 3 squared on 2 to 5. Okay, first of all, if you look at this function, so we see that f is continuous on that interval. This is very important, very crucial, yes, because if it's not continuous, then this may not happen. Okay, and then we want to calculate the average value of the function. So what is the average value of the function? Is 5 minus 2, and then you integrate from 2 to 5, and then you have x minus 3 squared dx. I'm not going to do this integrals, it's just very trivial. And if you do that, you see that the average value is just 1. If you calculate the integral, so the average value is equal to 1. So actually, if you look at this graph, at 2, this 2 is just 1. 2 is just 1. So we have here a value. And at 3, 2, 3, 4, 5, it drops to 0. And then it goes at 5 to 4, yes? 2, 3, and then 4. So if you want to sketch this function, so it goes as such, basically. So this is this function, if you want to sketch it roughly. What we're saying is that the average value is just 1. This is the average value of the function. What does that mean? It means that this area, okay, can be filled here, actually. So this is what we're saying, yes? Right? Do you understand what I'm saying, Asham? Is that okay?
Yes.
Okay,
Clear.
so,
You
right.
mean you
So
could
what,
make a rectangle, right?
yeah, exactly. So this, yeah, this is our famous rectangle that has the same area as the original, under the original graph. Okay, so this is my average value, which happened to be 1, yes? So this is the average value. What we are saying is the following. The mean value theorem says that, hey, okay, fine, you did that, that's okay, right? Then this is your average value. Then you must hit the average value function somewhere in this interval. So what we're saying that f of c has to be equal to the average value of the function. So we want to find that c. So f of c is equal to c minus 3 squared. This is my function, isn't it? Okay. that should be equal to the average value, which is 1. Okay, now I will solve for C. So C minus 3 is equal to plus or minus 1. So Z equal to 3 plus or minus 1. So C is either equal to what? 4 or what? Or 2. Isn't it, Ashram? Yes? So what we're saying is that you will hit the average value at these 2 points. And this is true. This is 1. What was it? This is 2, sorry. This was 1. And at 5, this was, I think, 4. And at 3, this you hit the grounders. So this is my average value. This is F average. And these are the values of C. So this is one of them. And this is the other one. So this is C, this is C. What are these values?
2 and 4.
2 and 4. So you must hit this average value here. And you must hit the function here. That's what this is saying. Is that okay, Sean? Easy?
Yes.
It is so easy that you probably don't want to believe that it is easy, yes? So it's just as simple as that. Okay, so we have another example. Again, the same thing. There's nothing new here. I have this function, and this is on 0 to 4. And again, the same problem. Find the average value and find where the function hits its average value, right? So first of all, we calculate the average value, which is what? 0 to 4 function dx, and we have to divide that by the width, yes? Is that okay, Sean?
Yes.
Okay, so if we calculate that, you see that without doing any arithmetics, this is 4 over 3. Okay, what we're saying now, what is that C such that f of C is equal to the average value? Okay, so what is f of C? Is the square root of C, isn't it? Is equal to the average value. This is 4 over 3. So C is equal to 16 over 9. Okay, so let's see how this looks like. Okay, so this is the square root of x basically, and this is 4. And if this is 4, then this is 2. So therefore, I assume that this is 1, and this is supposed to be 1 also. So we're doing this from 0 to 4. So this is f. So what is the average value of the function? It's 4 over 3, which is 1 and 1/3. So this is the average value of the function. It's here. What the mean value theorem is telling us that between not interested in this, yes, between this 0 and 4, you must hit the average value. Where do you hit it? Yes, sir. Where do you hit the, exactly? So this is it. So this is your average value of the function, and then this is where you hit it. You will crash with the average value. And this is guaranteed by the mean value theorem for integrals, because the function is what?
Continuous.
Yes, exactly. So just like going from here to Riyadh, you will not miss your average speed. You cannot miss it. How would you? Okay, so now let me just give you a brief idea about now this course. We are in a position to tell you what Math 102 is. Okay, I'll just take 2 minutes to describe this course now. So what we've done so far, Shabab, we looked at in Math 101, we looked at the function, and then we looked at the slope of the tangent line, or the rate of change. Okay, we called it a derivative basically, right? And in Math102, given a derivative, you want to go back and find the function. So this is what you want to do. And we also represented that by an integral of f of x dx, basically. So you could have anything here, g, f prime, whatever. So you have something here, and you want to put that together. All right. So this is just like taking a small part. Okay, put that into the integral sign, you get the big part. Yes. Like what we said is that you take a sample here, take a sample here, put that all together, then summing them up. This means that you integrate them and you get the, for example, the big area. You get the surface of revolution, for example, the volume, etc. Right? Now, but there are integrals which are easy because we remember Math 101, for example. If you had x cubed dx, then you know that this is x over x power 4 plus over 4 plus a constant, and this constant is necessary because there will be infinitely many antiderivatives. If you differentiate any one of them, they will have the same slope. So that's why the constant is there. And we said that there are certain things that we are not happy with, because, for example, if you have some 3x minus 1 and this is a squared dx, you cannot say that this is not equal to 3x minus 1 cube over 3 plus a constant. The reason for that, if you differentiate that, you drop the 3, so the 3 will cancel, and you have 3x minus 1, this is a power 2, multiplied by the derivative of the inside function, which is a 3 here. So there is an extra 3 here that is not accounted for. So you can't just add a 1 to the power and divide by the nu all the time. You can do that if you have a simple x here. So this becomes x power 4. And we used to solve this using some substitution. Like say, okay, fine, u is equal to 3x minus 1, and therefore du is 3dx. So this integral actually can be written as u squared, and dx is du over 3. And if you look at this 3, that this has popped out here out of this. And we say, okay, this is 1 over 3, so this is Juha squared d Juha, and then we don't really care as long as this has the same letter. Yes, this is u squared du, x squared dx, z squared dz. It doesn't really matter. So we could do the problem, but there are certain problems that are really very difficult to do. For example, if you look at this x, 2x, and this is x squared plus 1 dx, then the appropriate substitution for this problem would be x squared plus 1. So du will be equal to 2x dx. And when we do this, it's going to be the square root of u, and this is a du, which we can do, yes? So this is u 3 over 2 divided by 3 over 2 plus a constant. And when we take a u, we take it from here, put it back again. So this was an easy substitution because we had sort of a derivative of the inside function outside there. But if you look at this integral, for example, this is the square root of x squared plus 1, and you go ahead and take it home and then struggle with next time it comes in, I don't know how to do that. See, this is not an easy integral. This was much easier. Yeah. For example, if you just have a u, which is x squared plus 1, so this is a du, which is 2x dx. All right, when you come to this integral, you want to do the substitution. So this becomes the square root of u, but dx is what? Is a du divided by 2x. And hey, you see, but I have to get rid of x. So this is a du divided by x. So what is x here? You get a u minus 1, this is x squared. So x is actually plus or minus u minus 1. It depends on which branch you're coming from. So this is a u minus 1. And if you look at that, this is quite complicated. Okay, so this is not simpler. In here, then we could get very, very simple stuff, and we could do it. So this problem is really difficult. Do you understand what I'm saying, Asham? Are you okay with this?
Yes.
Okay, so now, so therefore you realize that there are certain integrals which you cannot do. So now there's another integral. This is e to the x dx, which has an integral of e to the x plus a constant. That's easy. But if you insert just a simple x here, okay, and now this becomes really very difficult. So what is this? Now, so this is the body of functions that we really need to integrate. And in Math 101, we had a body of functions that we need to find the derivative for. And we said that we have all the tools probably that you need. Of course, with some certain special functions, then there will be a difficulty with finding derivatives, but the derivative in 99.9% of the time can be obtained in your cases. You can use the product rule, you can use the quotient rule, the chain rule, which is the most important, yes, etc. So you have all the tools by which you can find f prime. Now, if you want to get the from f prime, the derivative, you want to go back to the function. Actually, so like I've given you 2x at dx, and you want to go back to the function, which is x squared. They have to depend on Math 101, which actually means memory, yes. And for this problem, there is no such memory that will save you. Right? We did not we don't know how this was brought about in Math 101. Therefore, so you can understand that integration is really a construction process. It's really very difficult. Destruction is, if the word is right, is what I call differentiation. It happens in no time. You take for example, a year to build a building, 10 seconds to demolish it. That's easy. Building is just really very difficult, and integration is just the building of functions whose derivatives are given, right? So what we do is that we depend on our memory from Math 101, but that memory is limited, so we have to find techniques by which we could do functions as such, as this function. So what we will do next in this course, so we have learned the basics now. Okay, we have learned the basics of integration, and what integration is, which is the net signed area. And if we insist, we can also find the area, and that should help us in finding volumes, etc., blah blah, etc. Okay, but now that we want to find now methods of integration. So we want to find methods by which we could do something like this, yes, right? And the first method that we're going to do next time is what we call, of course, the substitution always comes first, which is the u substitution that we did before. If you have something like 3x squared minus 1 and then a 2x, for example, dx, try a u substitution, you might manage. Next step is what we're going to do, integration by parts. And we understand what this is. And of course, there will be some other integration techniques, and this is what this chapter is going to be all about. All right, so next time we will do a very important technique called integration by parts. And all of these are extremely simple techniques. If you learn them, you can teach them the following morning. Yeah. Is that okay, Shamam?
Yes.
Yes.
Yes, Doctor.
طيب, so what I want you to do now is I want you to go to website. Okay, go please to website, put your camera on.
Doctor,
Yes, sir.
are there gonna be questions like the first quiz where there's round to the third decimal point or whatever?
Yeah, you will be told what to do. Don't worry.
So we can use calculators.
No, you don't need a calculator. You will not need a calculator. If I feel like you need a calculator, I will let you know. You will not be able to use a calculator. You will not be able to use any other sources. You should stick to your computer. have your hand stable, screen, etc. Use your mobile phone for to take pictures, right, from the angle that we talked about. And please just do this quickly. I don't really want to go into this hassle of just telling you what to do every now and then. All right, please remove all material from your desk. Get a clean desk. What you need is a few papers and a pencil. That's all. Right. Get this really quickly so we can give you more time.
Doctor,
No.
do we have to submit a paper after the exam?
No, nothing. No, you will input all your answers directly to the keyboard. But please notice that you will have to have a password and the lockdown browser. And I just give you a test quiz for that, and for you to try yesterday or
Yes.
even before. Right. So I don't assume that you will ask me anything about this now. Please just put your camera in the right position, please. I will just share my screen now. Just a second, please. I will share my screen with you so you know you can see yourself. I will give you like 3 minutes to adjust. Okay.
Mister, I didn't know about anything about lockdown.
Yeah, when you get to the quiz, you will have to. But I give you a test quiz, Abby.
Is it the same as the OAM?
The same as Math 101. Same as Math 101. Okay.
So do I just run it and then enter the test?
Exactly. When you go into the test, it will ask you to run the lockdown browser, and it will run. Okay. Now, please notice, Shabab, if you have a narrow screen, just like this gentleman here, please look at my screen, please. If you have a narrow screen like this gentleman, you should enable the rotation of your mobile phone, which means that this you should look like this. Right? You should have a wide picture, and we talked about this. If you have a microphone or a headphone or whatever, please remove it. If you have a cap, also remove it, please. Caps, headphones, microphones, anything, calculators, nothing else in front of you. And please be in the exam position. I will check that one by one. I hate to say this, but if you are not in the exam position, I will terminate the quiz. We cannot say this every now and then. And this gentleman, yeah, Walid Hussein, you are sideways, Yabni. Can you see that? No?
Yes, but I don't know how to rotate it.
Well, this is what I said. I was in my office. I said, if you have a problem, you check with me. Right? Okay, yeah, Muhammad Abu Saud. Look, this is not wide enough, Yabni. You understand? Enable the rotation of your phone now. Okay, thank you. Okay, please check yourself. If you're not in the exam position, look at my shared screen. Make yourself comfortable, please. Relax. Just if you are sitting in the right position, this quiz is straightforward, simple. So don't panic, please. We are here just to learn. We're not here to give you a hard time. I have no intention at all just to give you a hard time at all. So please just don't panic. Relax. But also you have to abide by the regulations, Ashab. Let's do it and khalas. Okay, go to WebAssign and get ready, please. And mute your mics. No.
The quiz is not available yet, right?
It's not available. I will let you know. You need also a password for that. Okay. Right. So now I need to see your hands, ya Shabab. I need to see your face. I need to see your table and computer. Okay, Shabab. You must not disappear from the camera at any given time. You must not disable the lockdown browser. Okay, Shabab. So please just, when you open it, just keep it there and work. I will give you as much time as possible. The quiz will not take more than 20 minutes, but I'm going to give you something like 40 minutes. Okay, which is the double of the time that I estimated for you. Okay, the quiz is going to be available at 9:15 exactly, and you'll finish at 10. If you finish, please do not go away. Just stay in the exam position. Stay as you are, please. Just do anything, but stay in against the camera. All right. And do not ask any questions during the test, no matter what, Ashab. If you have anything, you have the chat room. See this chat room here? Okay. Then write whatever you want. I read it, I will respond to you. And if it is necessary, I will call you separately and I will talk to you. But please constrain this. Yani don't just write anything, even a simple question that is not really important, you can answer it yourself. Because I have, as you can see, 44 students. And if I have to deal with each one individually, then that is not possible. So please limit the questions to minimum if it is extremely necessary. Okay, Shaf.
Doctor,
So yes.
if I
Now,
finish early, can I close the web
no, you have, yes, you can, but you have to stay in the exam position. I still have to see you until 10 o'clock. I'm sorry for this, but this is what the coordinator is requesting us to do. Okay, the session is going to be recorded, Ashamam. Okay, I will stop the original recording, right? So that is the